So why don't you try this problem here? We've got three vertices of a triangle, so we've got A is a point 21, B is a point 46 and C is a point 82. And we want to find the equation of the altitude from A. So a picture paints 1,000 words. Let's have a look at this in the graphical calculator. So we have the point A, which is 21. We've got the point B, which is 46. And we've got the point C, which is 82. And we're looking for the equation of the altitude from A. So this is the point A, and the altitude comes down and it cuts this line here at right angles. So we're looking for the equation of this line here. So how are we going to find this? Well, if we've got the point on this line and a point on this line here, we can find the gradient of this line here. So if we've got the gradient in this line here, we know that the gradient of the altitude is going to be perpendicular to this gradient here. So we can find the gradient of the altitude. So then we'll have the gradient of the altitude and we'll have a point on the altitude. So from a gradient and a point, we can find the equation of a line. So why don't you go ahead and attempt that question? So have you tried it? Well, if not, pause the video and go and give it a go. The answer should be y equals x minus 1. So come back in a minute whenever you've worked through the example and you can check and see if your working's correct. So we're looking for the equation of the altitude from A to BC, and we know that we can find the gradient of BC. So what is the gradient of BC? So we'll say m BC is going to equal the y2 minus y1 upon x2 minus x1. So there's a b and a c. So we could say 2 minus 6 upon 8 minus 4. So the gradient then is going to be 2 minus 6, which is going to be minus 4 upon 8 minus 4, which is 4. So the gradient is minus 1. So the gradient of this line here is minus 1. Now we wanting to find the gradient of the altitude, but we know the altitude hits this line here at a right angle. So if it hits this line at a right angle, we can find the gradient of this altitude. So we know that minus 1 times the gradient we're looking for, which is our, just call it m, will equal minus 1. So that means that our value m must equal 1. So the gradient of this altitude must be a value of 1. So we know the gradient and we know a point 2, 1. So with a gradient and a point, we can use our equation y minus b equals m x minus a, and we just put the numbers in. So we can say y minus b, so this is going to be the 1, equals the gradient, which is 1, times x minus the a, which is 2. And then we just transpose this. We're going to have y is going to equal, well, we're going to have x, and it'll be minus 2, but whenever we take the minus 1 across, it becomes plus 1. So that's going to be y equals x minus 1. So that's the final answer. And again, if you want, you could go and put in the line y equals x minus 1 into the graphical calculator, and you can see what it's going to look like. Or equivalently, we could just put it in here. You can actually think about, what does the line y equals x minus 1 look like? Well, you know the line y equals x goes through the origin and it's got a gradient 1. But the line that we're going to have is y equals x minus 1. So again, it goes through the origin, it's got gradient 1, but it passes through the point minus 1. So it's coming from this point down here, which is 0 along 0 down minus 1, and it's got gradient 1, so it'll go along 1 and up 1, so it'll go through that point, and it's going to go that point, and that point, and that point. and this point here. So it means that the equation y equals x minus 1 is going to go like this. So this here is going to be the altitude, and it's going to sit at right angles to this line BC.